Okay, so now we're going to talk about quadratics and introduction. So first off, the general shape. Technically, the general shape of a quadratic is called a parabola, which you probably know. I won't dock you for spelling, but it's P-A-R-A-B-O-L-A is what the shape is called. Okay. So a quadratic is of the form in general y equals x squared. We've seen that from the parent functions. Symmetry. Quadratics are symmetric vertically about the, right? This is to be the axis of symmetry of the quadratic, which is the line x equals something, right? Which represents the x coordinate of the vertex. So quadratics have a vertex. Sometimes the vertex, so this is some point A, B, right? Sometimes the vertex is a relative minimum. Sometimes, well, actually, I'm sorry, it's not relative. It's an absolute or global minimum because it is the lowest value. Or it could be a global or absolute maximum. That is the highest or the lowest that the thing gets. Please bear in mind that unless there's something special about this quadratic, like we're trying to find the inverse or something, that it has a domain that is unrestricted. That is negative infinity to infinity. Quadratics have a y-intercept. In this case, the y-intercept and the vertex happen to coincide. They don't always do that. So please bear in mind that quadratics have quadratics are always going to have a y-intercept. So if I got a quadratic like this, right? Move this sucker around. Sometimes it could have any sort of y-intercept, but it's always going to have a y-intercept, even if it's down here, because remember it's going to keep going up and up and up. It's always going to have some value for the y-intercept. But in terms of zeros, roots, or x-intercept, which are all the same thing, quadratics can have at most 2, which happens to coincide with the squared part of there, right? It could have 1, like this or this, right? That is just touching the axis. Or it could have no real roots, okay? When we say real, we're talking about this being real numbers. End behavior are or is what the ends of the graph are doing. So quadratics, you have two choices. You could have something that's opening up like that, or something that's opening down. So end behavior, a concept we need to get comfy with, is what the tendency is as x tends towards positive infinity and as x tends towards negative infinity. Now please bear in mind in terms of x, positive infinity is this away, right? It's just a direction. That's all these positive and negatives are anyway. Negative infinity, x tends toward negative infinity, be that way. So as we get larger values or smaller value of x is another way to think about that. What is happening to the graph? That is, what are the y values doing? X tends towards positive infinity. I'm sorry, you usually use a comma. Y tends towards where? Y tends towards where? We'll show you how to combine these in a single statement if you'd like. But in this case, as x tends towards positive infinity, y is tending towards negative infinity, this direction, right? So that's negative infinity, that's the y direction, positive infinity would be this way, right? So if you're looking at a quadratic that opens up, it means that both ends are heading to positive infinity or both ends are heading to negative infinity. This is always going to be true of any quadratic. The end behavior is going to be the same, meaning when we're heading to positive or negative infinity, it's either going to be both positive or both negative infinity. Hint, looking up, here they both opening down, okay? There are several different forms of a quadratic, so we'll go with our good old function notation, is of the general form ax squared plus bx plus c. That would be the polynomial form. I'll give you a hint. C is the y-intercept, okay? A is the vertical stretch, if you remember that, okay? So let's write that down. A is the vertical stretch. C is the y-intercept, okay? Now, there's also something called standard form, aka vertex form. I'm personally much more in favor of vertex form, but you may see standard form, is of the form where A is exactly the same as this A, and it's still the vertical stretch, kind of good to remember that this a and this a are the same number. But I used h and k here because they're different than b and c. H comma k is the vertex. Meaning, if that's a positive, that means a positive value, you know, plus positive, right? Think about the vertical shift. Here, it goes the opposite. So it's minus h, which means it's actually a positive value for the vertex. Think shift left to right. Hopefully you have not forgotten that. Factored form. Here's a again. See a? So a is still the vertical stretch. M and n are zeros. In other words, x equals m and n are when y equals 0. Now, this is in the case that you have a quadratic that has 2 roots. You may end up with a quadratic that only has 1 root, and it's going to be more of this form, where that root has to be repeated. Remember, in order to be quadratic, it has to have an x squared, and if you distribute this, you get your x squared. Here, if you distribute this properly, you'll get your x squared. Remember, that's x minus n times x minus m. Okay? And that's all we've got for this particular segment of our quadratics extravaganza.